Welcome to ET, everybody. My name is David Stemmer, and I'm a mobile engineer at Chariot Solutions. Today I'm going to be talking about RoboSpice, which is an asynchronous networking library for Android. So RoboSpice is an open source project. It was created by a company called Octo Technologies. And is still maintained by them on GitHub. And they have graciously allowed us to use some of their slides today, so that's why you'll see their name stamped all over the slides here. So we've made some modifications to them, tried to bring them up to speed for people that are not that familiar with Android, so we added a couple of extra ones in there. But many thanks to our friends at Octo Technologies for making this possible. So what is RoboSpice? So RoboSpice is a robust, high-level networking library for Android. Well, first of all, how many people here, just to get an idea, have actually used Android? Show of hands. Okay, so a lot of people have used Android. How many people have programmed for it? Maybe about half or so. Okay, it's a pretty good number. Asynchronous networking on Android isn't easy, unfortunately. It's not easy on any mobile platform, really. So what RoboSpice gives you is sort of a networking framework. And I call it a framework because it really consists of a stack of interrelated networking tools for you. So what can RoboSpice do? RoboSpice can help you queue your network requests asynchronously, and it manages a task queue of network requests. It's concurrent, so you can fire off multiple requests at the same time. It does a lot of the initial setup of requests for you and handling of responses. It will help you parse your response data. For example, it will allow you to bind JSON and XML data to POJOs, plain old Java objects. And it does so through the interaction of a number of plugins that it has. It has plugins for Jackson is one of them. It's a popular data binding library. Has plugins for JSON, which is a Google data binding standard, and for Simple XML framework, among others. So it's very powerful. It also allows you to cache your network requests. So it'll take data that you parse and it'll actually save them to persistent storage. It has a couple of types of persistent storage. It has sensible exception handling, which is very important as the program gets large. And it does this all in a way that's intuitive and very easy to manage for application developers. So for people that aren't familiar with Android, I'm just going to go over a presentation outline here. The first thing we're going to talk about is we're going to give a little bit of an overview of the Android application lifecycle. Just so that people know how an Android application works, how it's different from a regular desktop application, and how that is relevant to networking. So after we go over a little crash course in Android, we're going to talk a little bit about the typical approaches to asynchronous networking on Android, including async tasks and loaders. And then we're going to talk about some of the limitations of each of them and sort of the motivations for a library like RoboSpice. Why do we need it, and what does it have to offer developers? So throughout the presentation, I'm going to be pausing at different times to take questions. But if anybody has a question at any time, just raise your hand, and don't hesitate to interrupt me by raising your hand. This is Philadelphia. This isn't San Francisco. We like to interrupt each other. So. Without further ado, let's begin. So if you're an Android application developer like me, you tend to write a lot of the same types of applications over and over again. A lot of mobile apps are content-driven, and they rely on data from a remote source. So typically you have a number of client applications that are connected to a web service, and this might be a RESTful web service, it might be something that exposes a SOAP interface. There's a lot of different kinds of web services. And the web service is typically backed by some sort of database, either a relational database or a flat file database. This is going to be familiar to anybody that's worked with client-server architecture. You know, it's not like rocket science. So why is writing network requests so hard then for Android? You know, this is a pretty simple sort of idea. So to understand why mobile poses particular challenges for networking, I'm going to overview sort of what an Android application looks like, and hopefully it'll become a little bit more clear. So anybody who's looked at the Android documentation is probably familiar with this diagram here. This is a diagram of the Android application lifecycle. So you can think of an application on Android sort of as a process. So every application on Android is tied to a single process. And within each process, you have a number of what are called activities. An activity is sort of analogous to a single screen. It's a little more complicated than that, but for the purposes of demonstration, that's the way you can think about it. So you have an application tied to a process with a stack of activities that are being created and destroyed all the time. So for example, when you have an Android application with a home screen, your home screen is going to be one activity. Maybe you would click on a list item and go to a subscreen, and that would be another activity. It might have a detail view as another activity. And then when you go back, it'll pop the activities off the stack. So this is sort of changing all the time. So, so thing to sort of understand about this diagram here is that your activity goes through a number of different states throughout the life cycle. So when your activity is first created, when you show a screen, it fires what's called a lifecycle callback method, which is that onCreate method over there. After the onCreate method is called, it goes into the created state. Then when the activity is destroyed, it calls the onDestroyed method, and it goes into the destroyed state. So, so you know, there's a lot of different kinds of states in between, and you use these lifecycle callback methods to set up a lot of your application architecture. So in the onCreate method, that's where you might create your views from an XML file, inflate them so they can be shown on a screen. In the onStart method, that might be where you put some of your refresh data. So if you need to refresh the screen after you come back from another activity, maybe some of your data has changed, that's where you put it. But the thing to take away from this is that an Android activity is not static. So at any given time, your activity can be moving through all these different states, and it can be unpredictable. So if a user gets a phone call, for example, your activity might suddenly move out of the resume state into the pause state and then into the stop state as the screen is hidden. Then maybe as they come back to it, it'll move it back into the resume state, or maybe they'll never come back to it. And it'll sit in the background for a while until Android reclaims it from memory, and we'll call the onDestroy method. So is this clear to anybody? Anybody have any questions so far about the activity lifecycle? So the important thing about this as it relates to networking is that the life cycle of a network request, for example, fetching some image data from the server, is often longer than the life cycle of the activity. So for example, you may have a typical use case is when you have an activity, you need to populate it with some data. The activity goes and it fetches some data from the server. Maybe it needs to fetch a JSON list with some information about each item in the list, and then maybe it also needs to fetch an image for each item in the list. So as that's happening, it's likely, and it's even very common for the user to navigate away from your activity. So in that case, you have a bunch of network requests that are now unfinished, and their life cycle is sort of not synced up with the Android activity life cycle. So one of the particular challenges of networking on Android is how to handle this problem of network requests that just last longer than you expect them to and longer than the actual activity exists that is managing them. So we're going to go over a couple of different proposed solutions to this problem, and we're going to go over some of the limitations, and we're going to talk about why we actually need a networking library to help us handle this type of stuff. So any questions so far? Okay. So the most common, I would say that probably the most common way of doing asynchronous processing on Android is something called an async task. An async task is something that has been around on Android for quite a long time, probably I think since the beginning, or at least one of the very early API levels. And what an async task basically is a way to encapsulate asynchronous code on Android. It's basically an object, and it's actually an abstract class with a number of methods that you have to implement in Java. And it has a number of different methods that you can use to handle different parts of the asynchronous operation lifecycle. So the most important one is this do in background method in the middle here. And this do in background method is where you're going to do all of your asynchronous work. So in the case of making a network request, you would have an async task and you would implement the do in background method. The do in background method would do all of the necessary setup work for your network request. So it would set all of your HTTP headers. It would set what get method you want to use if you're doing an HTTP request, get method, post method. It's where you would do any of the configuration and then make the actual request and handle it and parse the response. Then you've got a number of other different auxiliary methods here. You have this onPre-execute method, which you can use to do stuff prior to the asynchronous operation. So all of the methods here that are blue are executed on what's called the UI thread on Android. On Android, you have UI threads and you have background threads. So if you need to do some work on the UI thread while the task is in process, these are the methods that you use. You use onPre-execute if you need to, for example, display like a loading spinner as the network operation is happening. You could use onPost-execute to close it and maybe pass the data back to any listeners that need to use the data to update an adapter or something like that. And then you can use something like onProgressUpdate in order to display updates for the running operation. So if you're displaying something like a download queue and you need to display like 10% downloaded, 20% downloaded, 30% downloaded, that's what you would use. So this is pretty simple and it works for a lot of very simple things. But there are some problems with using async tasks that people run into over and over again. Real quick, here's sort of what an async task might look like. This is a very simple one for fetching a list of people from a server. It has a do in background method, and they kind of hand wave that. That's where you would do your computation. An onPost-execute method where you would update your UI. So what is the problem with using something like an async task? Well, the problem comes back to the problem of the activity lifecycle, is that async tasks are not coordinated with the activity lifecycle. So an activity can die as an async task is executing, but the async task will continue to execute. So what does this mean for your code? This means that you may have an activity that fires off an async task, and then you have an action that destroys an activity. So a very common one on Android, a very common place where your activity is destroyed is when your screen is rotated and it goes from like a landscape layout to a portrait layout or vice versa. And this will actually cause your entire activity to be destroyed. The layout is recreated and you need to reinitialize everything. So in the process of that happening, a new activity gets created. But then what happens to the async task? Well, the async task is still working and it's still doing work in the background. It doesn't die when the activity dies. So then when the async task actually finishes, you have the problem of it now trying to update the UI of an activity that no longer exists. So in a best case scenario, this would do nothing. And in a worst case scenario, it crashes your app. And it can cause memory leaks because now your async task is holding references to an activity that no longer exists, and the activity can't be garbage collected. So until the async task completes. So there are a number of different problems with this approach. It's possible to work around some of them, but it's kind of difficult because you have to be very conscientious when you do it. So you basically have to shut down the async task every time that your activity finishes. And you need to add some extra code to the async task in order to make sure that it actually stops executing the callback. Because when Android tells an async task to cancel, that's all it does. It just sends a notification, hey, you should cancel yourself. All of the logic for doing that is sort of an exercise for the application developer. And in a large project, it can be hard to maintain, especially of lots of different developers working on it. Nobody's going to remember to clean up the async task when the activity dies unless you tell them to. And it becomes sort of a code maintenance nightmare in the end. So if anybody's, this is a real world problem. This isn't just like an academic problem. If anybody's seen like context leaked method, like window context leak messages in your like Android debug log, that's probably where they're coming from. You probably have an asynchronous operation that's trying to access an activity that no longer exists. So that's async tasks. And new since Android 3.0 are something called loaders. And I say new, but new is sort of relative in the Android world. It came out a couple of years ago, but phones are just getting it at this point. So they're not new, but people are just starting to use them more and more now because it's now usable in a wider application environment. So what is a loader? First of all, any questions on async tasks there? Because I know that it can be a little bit complicated to think about with asynchronous operations. Anybody?
So in addition to the callbacks that you listed there, you said there's also a cancel method that can get
yes.
called? So does that get called when your activity goes away?
No, it doesn't automatically get called when the activity goes away. So you have to manually call the cancel method on the async task. And I don't believe there is a callback. There is an uncanceled callback in the async task itself, but the problem is that it doesn't actually do anything. It just says, hey, you should cancel yourself. So that means that if you're making a network request, that means you have to manage shutting down any connections to the server, anything like that, throwing an appropriate error message and notifying your activity, assuming you have some sort of listener object that's attached to the async task. So yeah, so it can be a lot of work to do that, and a lot of people don't do the work, and they'll just let the async task keep running when the activity dies, which is it's sort of a at one point it's kind of programmer laziness, but in the other sense it's also it's not really a great interface. It's that Android really doesn't give you a very good way of like reporting errors for asynchronous callbacks. So we're going to talk about that a little bit more with RoboSpice and sort of how they handle it differently. Any other questions? So the loader API, the loaders are sort of the opposite of async tasks. Not the opposite, they still do asynchronous networking, but they work in a different way. So loaders are tightly tied to the activity lifecycle. So when the activity is created, the loader will actually start operating and start trying to load the data from the server. So the way it works is you have got a loader manager, and the loader manager is attached to an activity. So when something happens to the activity, like when it's created, the config changes, the loader manager is notified, and the loader manager will see what callback objects that it has on it. And depending on if the data is fresh or stale, it will go and it will fetch that data, and then the UI will be updated. So conceptually, it's pretty similar to an async task. So here we've got a little example of some loader code here. So here is an Android activity, which implements the loader callbacks interface. So you can see that it has this onCreateLoader method here, and this is where you tell the loader manager, what kind of loader this activity is going to use. It has the onLoadFinish method, which is where you handle binding your data that comes from the loader and binding it to the view. In this case, it looks like they're taking a list of people, and we are binding it to like a list adapter to display in a list view. And then we have got this onLoaderReset method. So when the loader is reset, we need to clear our list, and then we need to wait for new data, basically. And the loader itself, here's sort of a skeletal implementation of a loader. This extends the async task loader, which is sort of an abstract type of loader that Android provides. And it looks very similar to an async task. It's a load and background method and a constructor method for creating the loader. So Android does offer other types of loaders. Loaders are really designed to work with database cursors, which leads to one of the problems with them. So the problem with loaders is the opposite problem that async tasks have. Loaders are very tightly coupled to the activity lifecycle. So when you're making a request through a loader, that request is lost when you leave the activity. So if you're on a screen that is displaying like a list of items, and then you go to a subscreen or something like that, if the request is not yet completed by the time that you choose to navigate to another screen, the loader request actually dies. And then the next time you have to come back to the activity, it has to restart itself. So you can get caught in this type of loop. So that's one problem with loaders. The other problem is that, like async tasks, they don't really have any built-in method for exception handling. So if something goes wrong in loading it, it's sort of up to the application developer to figure out how to report that error correctly. So again, maintainability issue, and not really well suited to the task of networking, which often has requests that last longer than the activities last. For databases, it's okay because usually it's loading from a local database, and it doesn't take very long to load the request. But for networking, it's just not a great use case. So that's loaders. So I've tried to implement a loader, a networking type of loader, and I found it to be very frustrating. And apparently, a lot of other people found it frustrating too. So what we ended up with was this library called RoboSpice. And that's their slogan: there is a better way. So any questions so far on loaders or async tasks? So how does RoboSpice work? So I'm going to take a little digression here and talk a little bit about Android services. So RoboSpice is actually based in the background on an Android service. And I'm going to talk a little bit about more how it does the request processing. But what is an Android service? An Android service is it encapsulates a long-running background operation that is tied to a particular process. So remember how I said that an Android application is basically like a process. You have a single process per application, typically. So a loader is tightly bound to the application lifecycle. A service is bound to the application lifecycle. So what a service is not bound to is the activity lifecycle. So as activities are created and recreated and die and go to the background and come back from the background, et cetera, et cetera, et cetera, the service keeps on running and it doesn't go away. So this is a very good use case for the type of networking scenarios that we're thinking about here. In particular, RoboSpice uses what's called a local service. So on Android, there are both local services and remote services. A local service, the distinction is that a local service runs on the same process that your application runs on. So with a local service, it's running sort of in the same area that your other code in. With a remote service, you're running in a remote process. So a remote process means that your code is kind of like in a sandbox that is separated from the rest of your application. The reason that they chose with RoboSpice to use a local service is that with a remote service, you have to deal with something called inter-process communication. And inter-process communication means that in order to pass data between your activities in the service, you need to marshal that data. You need to basically serialize it, turn it into primitives, so that the data that the service in the remote process can handle it. And then if it has any information to pass back, it also has to marshal that data. So when you're dealing with complex objects, like exceptions, like any sort of Java object that consists of a graph of related objects, it's very hard to pass these between different processes on Android. So RoboSpice made the decision to do this as a local service, which is more complicated because they have to deal with their own threading issues, because processes normally run in their own threads. But it's a very wise solution, I think, and it's one that works very well for the use case. So a quick overview of the RoboSpice API here. So you have an activity, and your activity wants to make a network request. And the network request has a request listener that's attached to it that's supposed to handle the callbacks and update the UI. So in order to talk to the Spice service, you send the request to the Spice Manager object. And the Spice Manager object is kind of an intermediary between you and the service. It does a lot of the message handling stuff. And the Spice Manager binds itself to the Spice service. Now you can think of the Spice service as sort of a singleton object. Most services are on Android. There can be multiple Spice Managers, but there is only one Spice service. So the request goes to the Spice service. It does some processing in the background. And then it notifies the listeners when the processing is done. And the listener updates the UI. So how is this different than an async task? It sort of conceptually looks very similar. Well, the difference is the way that the service persists throughout the life cycle of activities. So consider what happens when activity dies. For example, when the configuration changes when you go from portrait to landscape. So activity dies. All of the attached objects to the activity also dies. The request listener dies, the Spice Manager dies, but the Spice service keeps on trucking. So you have the Spice service now that is continuing to process the request in the background. So now when activity 2 becomes alive, this is the recreated activity after the configuration change. It creates a new request listener, a new Spice Manager, but it gets bound to the Spice service that already exists. So then it can continue the operation, basically, that was started by the other activity. Processes the data, notifies the request listeners, and the activity gets the updates to the UI it needs. And it does all of this transparently. There's no having to pass the async task from the previous activity to the next activity, which is something you might have to do. There's no trying to manage the life cycle of the asynchronous operation, so you have to cancel it when the activity dies. It's all very transparent to the developer. And the other nice thing about the RoboSpice service is that because it is a service and because it's a bound service, when nothing else is bound to it, it shuts itself down. So this is a property of bound services in Android that they've taken advantage of. So RoboSpice will clean up its asynchronous operations. It will clean up itself when it dies. And in general, it's a good citizen about just managing those types of things. So the Spice service can be used from any sort of Android context. And when I say context, I mean so there are different building blocks in Android. The activity is one of those building blocks. You also have the application object, which is kind of a global object that some people use to manage global state. You have other services, so you can talk to a Spice service from another service. This is good if you're doing like GPS callbacks in one service and then want to initiate a network request based on that, for example. You can also do it from fragments, which are kind of like little mini activities that operate inside your activity. So it's very reusable, usable in any Android context. So another major advantage of RoboSpice is the way that it does data persistence. So a common problem on Android is that you have a very unreliable network, and this is true of any sort of mobile development. You want to do as little network, as few network requests as possible, basically. So the way that RoboSpice helps to kind of alleviate this problem, it's pretty aggressive about caching stuff. So when you make a request to a Spice service, the first thing that RoboSpice does says, is this object already in my cache? And if yes, it will notify the listeners of the request success, pass the object back, and if not, it goes ahead and processes the request. And then when the request is complete, it saves it to the cache and notify listeners. And so it goes through this cycle every time that you make a request. Provides automatic caching. It also allows fine-grained control of caching. So you can say, I want this item to remain in the cache, only 10 minutes, or I want it to remain for a day. Or you can say, I want to clear the cache. It's very good. It's very transparent about allowing you to use the cache in the way that you want, or not use it at all if you so choose. So RoboSpice is basically as powerful as you want it to be. So how does RoboSpice handle errors? So we've seen this graph before. So now imagine that your request doesn't work, which is very common. So maybe you get a 404 error from the server. Maybe the user has turned on airplane mode and you don't have any connectivity. There's a million reasons that the request might not go through. So what RoboSpice does is it doesn't fail with no message. What it does is it will complete the request, but it will notify all the listeners that the request has failed. So what it actually does is it passes back an exception object to the attached listeners. So activity will say, hey, we got a RoboSpice error. You can look at the exception object, and that exception object will have a list of chained exceptions that will show you, where the error originally occurred. So this is really great. This is one of the advantages of having RoboSpice as a local service. You can pass these rich objects back and forth, which you wouldn't be able to do with a remote service. So that's how RoboSpice does exception handling. Any questions so far on any of this?
Question, it's gone back a little bit.
Sure, no problem.
So when you talked about the activity lifecycle integration, and we had request 1 and request handler 1.
Sure.
And then the activity died, and we had request sub 2 and request listener sub 2.
Yes.
Magically, request listener sub 2 got the callback. In what way does the Spice service know to send the request listener sub 2 like the data, because it didn't?
So there is a binding method. We're going to take a look at the end, a little bit of RoboSpice code. So basically, when the activity is at a specific point in the activity lifecycle, usually in the onStart method, you will actually bind to the Spice manager. And what the Spice manager does is it will set up a binding with your Spice service. So you need to basically implement two calls. You need to implement a method that will bind to the Spice service and unbind from the Spice service in your two lifecycle callback methods. So that's pretty much the extent of the setup work that you have to do for it. You need to do a little bit of service configuration too, to tell it like how many threads that you want, but other than that, it's pretty straightforward.
So, I see. So the request listener gets any callback from the Spice service?
Yes.
It's not specific to a request?
No, well, it doesn't get any callback from the Spice service, no. The Spice service knows which activities should get which callbacks.
Even if it's a new instance of that same activity?
Yes. All right, let's move back forward. So this is some example code. I'm not going to go through this right now because I'm actually going to show a demo of some working code that I have, an application, a sample application using RoboSpice. So let's just skip that for now and talk about some of the feature set of RoboSpice. So we've already talked about some of these, but just to go, give a review and go a little more in depth. So RoboSpice provides, at its very basic, it provides REST operations out of the box. And has a couple ways of doing this. It can do it through the built-in type Spice requests, which use the Android built-in request objects. But it also has a couple of plugins. So if you prefer to work with something like Spring Android or Google HTTP client, it has like Spring Android Spice requests and Google HTTP Spice requests that you can use to integrate with either one of those frameworks. And it has a fully object-oriented API. So you use POJOs, plain old Java objects, to send your request parameters, and you receive them as POJO objects. And there's a number of different libraries that plug into RoboSpice that can help you to do the data binding. I've already mentioned some of them, but Jackson's a very popular one, which is built into the Spring Android module, Spice request. And the other one I've been using is Simple XML framework, which makes it very easy to bind XML data to Java objects. Provides automatic caching. I've already mentioned XML JSON. It also has integration with ORM Lite, which is a sort of an object relational mapping library for Android that lets you interact with local databases in an object-oriented way. And it also supports your regular objects, text strings, binary data. And since the most recent version, it also works with binary data and binding them to bitmaps. That was a contribution that I made. So it's very powerful with the types of data that it can handle. This is most of the type of data that you're generally going to be working with in an Android application. It's good about memory leaks, easy to use, and it is Maven ready. So all you need to do if you use Maven is include the correct information in your pom.xml file, and it'll automatically download all the dependencies for you. So it's pretty simple. And it is available on GitHub. So the RoboSpice people are very, very responsive. They're very accepting of pull requests. And their mailing list is also very active. So anybody that's interested in learning a little bit about it, they're very friendly to newbies. They don't yell at people for asking stupid questions. So it's a very good place to be if you're interested in doing this type of thing for Android. So at this point in the talk, I'm going to go through a little bit of a RoboSpice application. I know that we are approaching the lunch hour, so I'm going to try to be brief about it. We're going to go through it and sort of see some of this in action and see how all of these moving parts work together.
Before we do that, I have a question that's maybe an Android question, but I'm wondering, as your application is closing, so it's not like the activity is changing, but the app is shutting down, what are the limitations there? I have a request that needs, I really need this to go out to the server, Is there like a time frame there, or does RoboSpice do something to help you make sure that gets out?
So this is a very good question. So because RoboSpice works in what's called a local service, it is actually bound to the process that your application runs in. So that means if the process dies, the service is going to die. So if your user totally closes out of the application, like hits the back button until the application is totally closed, or if the system decides to reclaim the memory, which Android sometimes does. If it's low in memory, it will shut apps down that haven't been running for a while, and it will do so in a kind of aggressive manner. it'll kill the Spice request. And that's one of the trade-offs that you have to make when choosing whether to use like a local service or a remote service that's going to run in its own processes. Because remote services can exist independent of the application lifecycle. So Android does have a number of built-in ways for handling like really long-running operations that need to happen beyond the activity of the application itself. I believe that one of them is the download manager, but I haven't used it myself, so we could talk a little bit afterward, maybe about solutions if you have a particular problem that you're trying to solve. Any other questions before we start looking at some code? Okay, so I'm going to close out this PowerPoint presentation if I can. I may need to do some screen switching here. All right. How do I mirror displays here? Oh, gather windows, that's right.
If you go back, mirror, you can mirror right there, arrangement.
Where is it? Oh, arrangement.
And then
Okay, there we go. Okay, how can I maximize the editor pane? All right, so let me. This code I'm going to run is a sample that is now part of the RoboSpice samples project that I contributed to the project, and this is showing how to use RoboSpice for image caching. So one of the motivations for me using RoboSpice was that we had an application that needed to display a grid of images. And there are ways to do caching on Android. For example, you can use something called an LRU cache, which has been built into Android, I think, since Honeycomb, and they have support for it back with the support library. But even if you're using an LRU cache, you need an LRU cache that will exist beyond the lifecycle of your individual activity. So for us, RoboSpice happened to be a very good use case because I already had the service running in the background. It already had object persistence. All we had to do was build the correct type of object persisters that will take your request data and will put them into a database. And it's using a two-level image caching scheme. It has an LRU in-memory cache, and it also has a disk cache. So for anybody that's not familiar with how an LRU cache works, it stands for least recently used. So it takes up a certain amount of memory, maybe a megabyte of memory or so. Android applications are very memory limited. And it will put images into this cache. And as the cache fills up, if it needs to put another image into the cache and the cache is full, it'll say, hey, I'm going to kick out the least recently used image in there because that's something the user hasn't looked at in a while. So it's a two-level cache, so it has that LRU cache and a disk cache. So if something's been kicked out of the LRU cache but now needs to be accessed again, it will try to get it from the disk cache. If it can't get it from the disk cache, it will go ahead and it will try to get it from the server. Oh, am I running low on power? How much power do I have? 10%. I think 10% should be sufficient to get us through here. So apologies, this is running in the emulator, so it's a little bit choppy because it's not hardware accelerated. But it's very fast in the actual application. So these are photos that are all loaded from Flickr here. So you see as I go in the screen, it will load the images. And if you fling them, it waits until the fling's over, start loading them. And if I go backward, it will load the images almost instantly because they've already been cached already. So let's take a look at how this works. And let me see if I can remember the command for making this full screen because commands are sort of arcane. There we go. And blow this up a little bit so that people can read it. All right. So, so as I said, sort of the core of RoboSpice is this Spice service. So the first thing we're going to look at is this Spice service. So this is our Spice service for our application, and it extends a Spring Android XML Spice service. So, so that gives you a lot of built-in functionality already. So the important thing to look at is this create cache manager method. So this is where we set up all of our bitmap caching stuff. So we create a file persister object, and this object is what's going to save our stuff to disk, and an LRU cache bitmap object persister, which is a little bit of a mouthful. But you set the size of the in-memory persister, and it's basically, it allows you to pass in another object persister as sort of its second level cache. It's sort of like a decorator type pattern. And then you add the object persister to the cache manager. So this is pretty minimal. Your Spice service, your basic Spice service already has a lot of methods for you, and you only have to override a few of them. This get thread count one tells you how much concurrency, how many requests you can make at once. Just give you an idea of sort of how much the Spice service does for you. You know, there's a lot of code here, and it does a lot of stuff to make sure that you know, that's thread safe and that it's cleaning itself up correctly. So along with the Spice service, you have Spice requests. So here's an example of a Spice request. Actually, here's a So here's an example of a Spice request. This uses the Spring Android Spice request, and you know, all you're doing is passing to a URL, and you know, and it does a little bit of work for you. So it'll put some parameters into it, you know, set up your REST path correctly, and then it calls this Spring Android get for object method, which will bind your object, your JSON object to a Java object. And by default, the Spring Android supports JSON just out of the box and XML out of the box. So you don't have to do all that much work. All you have to do is annotate your data objects. So here's an example here of a Flickr photo. And it has these attribute methods, which mean that your ID on your Flickr photo Java object maps directly to the ID property of your JSON or XML object. And you can rename them. So this means we're renaming this to fit, you know, Java camel case conventions here. And you can sort of compose these things too. So this is another object that consists of another. This is an element list here. So this consists of a bunch of Flickr photos which have them in themselves annotations. So it's a very declarative way of doing your data binding and parsing data. There's no stepping through, you know, your XML tree and trying to grab a million different properties out of them and running into like null pointer exception errors when something doesn't exist and stuff like that. So so the integrations with some of the other frameworks are very powerful in RoboSpice. And finally, I'm just going to show real quick the actual activity here. You can see we have an activity that does a little bit of setup work to bind your views and things. The important method here is your photo request listener object, which is just an inner class inside your activity. And this is where you would actually handle binding your view to data. And you also have this on-request failure method, which I haven't implemented right here, but this is where, like, for example, if you couldn't load your JSON data to get at these pictures, you would display like a refresh button or something like that, because oftentimes users go underground and then they come back up and they're like, oh, I don't have it, and you can hit the refresh button, or you can do a number of different things. You could do pull to refresh, you could display an error message. But the point is that it will always pass these exceptions to you. So you always have a single point of entry for handling exceptions in your application. So that's just a little overview of RoboSpice. There's a lot more to it. It's a large library and growing. They keep adding more modules to it, which is a very promising sign for a young library. So I encourage you guys to check it out. Check it out on GitHub. Try it out in your production applications. We're already using it in production now, so it is production-ready code. If you have any problems, talk to them on the GitHub mailing list. They're very responsive. I guess that's about it. So thanks everybody for coming.